your school is the one that I was in when I was 6 years old. The military called me outside. It took me a while to get downstairs. I'm from South Africa, came to the US to study about 13 years ago, went to MIT. I started life as an architect, and my professional career as an architect, and then I decided to study engineering after that. I wanted to be a doctor, I wanted to be an inventor, I wanted to be a race car driver, an assassin, all these things. But I ended up designing medical devices. Spoonie is one of our latest projects, which, you know, when I say latest, we've been going at it since 2011. A friend was feeding his baby. He was one of the guys that got to go to MIT in the first place, 3 years before that to them. He said, you know, baby spoons don't work. He showed me what his assessment was. He said, most baby spoons are too big for a 4-month-old, 4 to 6-month-old to transition from fluids to solid food. He showed me how he bypasses the failures of current spoons. And I observed him, I videotaped him, I went back to the lab, and we sent back and forth between, at that time I was based in Germany, setting up a manufacturing line for the diabetes product, which I'll discuss next. And we were sending 3D prints back and forth between Berlin and Boston. We would test them on his kit, and they send me photos and video of what works, what doesn't work, what he prefers. What became a styling exercise first, and to reduce size and introduce portion control, ended up with us noticing on the video tests that the kids were performing, just eating better with some of this produced, as opposed to using the whole selection of just small spoons. And we figured out that there was a very unique ridge on the back edge of the spoon that we created as an aesthetic design first, but that actually had a very prominent functional feature that would trigger the upper lip turbo motor control response so that the baby would match and suck and swallow the food in one motion, as if they would eat it from a bottle or a nickel. So we made the spoon, we launched it on the crowdfunding, we were using Indiegogo, we raised just shy of $40,000. We got some additional investment of about $300,000 to scale the company. We sold about, I should know these numbers off by heart, I think it's 15,000, 16,000. We sold another 5,000 this week. So we're starting to accelerate. Now we're looking at how do we build a model to replicate distribution success in major markets. So in South Korea, we have our most successful distribution platform. So we're using that model and saying, how will that relate to the US? How will that relate to Japan, to Europe? And trying to build this company to sell about 250,000 units by the end of the year. In addition to making this, we are designing 4 new baby products for this brand, and we own this company. So it's part inventor, part business manager, part some stylist, aesthetic SAR to make sure everything looks good. So it's a fun brand label. We also made a wood version. These wood versions are very selective. We only have about 1,500 at a time, so we can't yet sell it in big box retail, but we're talking with Whole Foods and West Elm, trying to get this distributed throughout the US first. One of the next products for that brand is a pacifier. Have any of you ever tried to give a baby medicine? Have you ever tried to give a cat or dog medicine using a syringe? You have, right? Okay, now, kids get medicine, all of you receive medicine the same way with a syringe, like your cat or dog. So I have an issue with that, because I have a new kid, she's 11 weeks old. So it doesn't work, right? And why does it not work? Yeah, so the kid behaves the same way that the dog or cat is going to behave. Now the problem with that is you can just give it more, and hopefully you give them enough. But with babies, 5,000 to 10,000 babies get liver damage from Tylenol, infant Tylenol, because the parents look at what it's putting out, they're like, just give it more. The problem is that you can actually get long-term liver damage from getting too much Tylenol as a kid. So we designed a pacifier that combines a pacifier to promote the latching response with a syringe and dropper concept. So you can squeeze this to accelerate the rate of medicine ingestion. The kid is already latched on, and as a result, they're ingesting the medicine. Or you can let them suck at their own pace. There's a tiny valve in the back here. It's a one-way valve, so you can't push it out. You just push air in. And that allows them to consume the medicine at their own rate. It's fully transparent, and you can at any given time see exactly how much the kid consumed.
Has it been tested actually?
Yeah, so it works. We're in the final stage of testing for this now. The problem with kids' products and kids' medical devices, if you want to really make sure that it works well, you need to invest the money and manufacture the first batch, then test that batch. You can't sell it, you just manufacture it the way that you would make the final product. Then test it, and then scale up the production. So that's where we are right now. It's an FDA Class 1 product. It needs to be registered with the FDA. We need to confirm that we're using all material safety standards. So it's a very difficult process to move through, but not impossible once you understand it. It's 2015 now. How old were you guys in 2008? 8 years old? So when you were 8 years old, my friend had diabetes. He said we would love to have a timer, but just tell them when last it took his injection. So we move on 8 years. This is finally for sale in the US market. We did a major distribution deal. End of last December, we got the deposit about 6 weeks ago, and it's the biggest order to date. So we're shipping 115,000 of these units to the US, and it's now sold in more than 60 countries. We got the US patent approved, it's FDA approved, and we have a major US distribution deal. If you're making a medical device, those are the three things that you want to hit. You want to make sure that the US works your part, because the US is a major market. And even for diabetes, injectable drugs, you know, the diabetes market has 30% of type 1s, or 1/3 of the market for type 1 diabetes patients use insulin pumps. And those pumps are very nifty tools. They automate the way in which you consume your insulin. But the other 70%, or 2/3 of the market, they don't have access to those pumps. So they're either going to use a injectable pen, which is one of the major sort of increasing market segments, or they're going to use an old-style syringe and vial, which we're trying to get away from. So who's got the pen right now? Okay. So I don't know if you notice just the user experience of that pen. You remove the cap. You've got to remove the cap. I tend to take an injection. What does the timer do? Describe that for us.
Sorry. Oh, this one?
Yeah.
It is flashing right now.
Okay. Did it reset?
Yeah.
So what we did is that cap is, it was successful in a couple of ways. First, it bypassed all the pharma patents out there. So it wasn't the first time somebody wanted to put a timer on an insulin device. Just no one had ever dared to put it on the cap, because everyone wanted it to be on the body, be a sub-brand, a major pharma brand, and then they wouldn't sell many units because they were too expensive, the insurance didn't want to pay for it, and then they would fail and they'll make another one and another one. So that Eli Lilly, Sanofi, and Novo Nordisk, they're the three biggest suppliers for these style of pens. And they had patents. We figured out how to bypass those patents by just making a new innovation. All that is a stopwatch with a paddle switch on the inside. And when you push the pen back in, it's counting. And when you take it off, it flashes, but it doesn't reset. It only resets after 8 seconds. Because we figured out we need to give normal people the opportunity to change their mind. You take it off, you're about to set your dose. The phone rings, you put it back on. You shouldn't lie and tell you that you took your injection. So 12 seconds was the fastest that we could get people to take off the cap, put a needle on, even if the needle was on, dial the dose, take an injection, and then put the cap back on. So we made 8 seconds the threshold through that research, after which it would reset. And you as a user know that. It doesn't miraculously measure whether you took it. Following on this, we actually said there's a company in Boston that is doing very well. They're about to launch a product as well that is a much smarter version of the same idea. It's Bluetooth connected, the dosage tracker that connects with your smartphone, and your insulin, your blood glucose monitor. And eventually what we'll see is with this sort of micro sensing and sort of the miniaturization of components, is that you're going to have your blood glucose monitor and all your connectivity and all your measurement in one cap. And we're about a year away from seeing that as real products. This was a handheld microscope called the binocular for a Swedish gynecologist, and it's a non-invasive test used to screen the cervix for cervical cancer. And the competing technology that only 10% of the world has access to is only 60% effective in sort of determining whether you have early stage cervical cancer or not. So that's currently, for this we built a team. There was a global team of industrial designers, LED engineers, and sort of optics engineers. The optics engineer was an interesting guy. He designed spy satellites for his day job, and then we got him to make a tiny little microscope as an alternative application of these optical engineering skills. This was it's one of those fun products that I show always to remind people why you should choose very carefully what you spend your time on. So General Sensing is a company that I still own shares in today. Used to be based in Boston. I started with 5 MIT friends. It was fun, we had lots of money. It was 2006, we just out of school. And we made a social networking tag for dogs, so that you can know what your dog is doing. And I get that from all the time. You know what
I'm confused. Can you explain
Yeah, so-
what it does?
Yeah, so it knows, it's a very expensive piece of hardware. It was at the time, it cost us $123 to make one of these systems. And that, what it does, it's a state classification device that knows what a biped or quadruped is doing. So we put it on a quadruped, and we track using video mapping, basic states, and then we did scale mapping, the same states with different scale quadrupeds. Small dog, big dog, horse, and then human, so that you know when the dog walker leaves your dog at home and he carries the tag in his pocket, we know that it's a human that walks around with it. So super cool tech, very expensive. We all thought that we were very smart, and then we sold only 500 units when we launched it as the stock market crashed in 2007, 2008. It wasn't a good time for the yokers to buy dog tags. Our discounted retail price was $300, and we realized no one's going to buy this thing. But the technology was cool. Everyone wanted it for logistics, for the military application, for soldier asset tracking, for for healthcare. So 18 months before we launched it, we started the company out of the parent company that we moved the company to Hong Kong, and we made MedSense. Now MedSense is a hand washing compliance tracking system for hospitals. So you gamify hand washing compliance. And hand washing compliance is the biggest deterrent to hospital-borne infection, which in the US alone is about $5 billion market in the US. So this knows whether you are using the alcohol dispenser on the wall, whether you are using the sleeve on the alcohol dispenser in your pocket. Your ID tag knows where you go, who you interact with, which doors you touch, do not touch if they're automated. It knows when you're at the basin, how you're washing your hands, and if you're washing it. Because it senses, it knows the water contact, it knows the vibration of your hands go to the tag, and it just knows how good your hand washing, how good it is. And it's based on so we made a whole gaming system around that, so that we could flag people who are really sort of just going against the grain on purpose, and just gently nudge people who may forget here and there. And this is working very well. It's been tested in 8 hospitals around the world. As big data became a huge market, we figured out that, hey, we already have all the hardware, let's make a data company as well, and that's what's happening this summer. So we're using the same or similar hardware, and building a data company that knows how effectively hospital units are working, that can understand how to increase throughput in hospitals, and we can achieve in some wards up to 50% optimization of sort of accessible space. I don't have the image for the project, but in 2009 we did this, sometimes you want to manage the design process and inspire other people to do great things. So in 2009 we worked, we had a company with Topo that worked with the advertising industry and a couple of big brands to figure out crowdsourced innovation. Now that it's a general term, so you put an idea out to the group, to the internet. And there's a couple of crowdsourcing sites like 99 Designs and Uvoto and a couple of others. We said, can we design a better paper cup? Or can we design something that requires us not to have a paper cup so that we don't throw away 58 billion paper cups a year? And so we worked with Starbucks. The project, we got 500 submissions for this design challenge that we set out. And the one that won was called Karma Cup. And Karma Cup basically rewards every 10th person for bringing their own cup into Starbucks. And as a result of the reward is that you get a full free coffee, not just 50 cents coffee, because none of us will do that for 50 cents, carrying big money all day round. But if there's a chance that you are going to get a free coffee, whenever you go to Starbucks, if you're that one person, then you might make that. Okay, I just want to go out of this for 1 second. Let's just see here. That's not too dramatic. Sorry. I just have some additional slides that I want to show. Okay. So, back to Spoonie, we have about 17 projects currently running at in the Navy Yard. If you guys want to ever come in for a tour, just bring the whole class. They'll be there.
Could you explain the Navy Yard to them?
Yes, I'll do that in a second. We have well written down. So the Brooklyn Navy Yard is where you used to be it's still across the river. It's one of the oldest working harbors and construction harbors in the U.S. It's where they built most of the wartime fleets up until the 1950s. They built aircraft carriers, battleships. They have 5 dry docks there. The last aircraft carrier they built there was in the 1960s in the Korean War, it was the late 50s, I can't remember the date. It was decommissioned in 1966. It's a 300-acre site. It's the equivalent of some of the biggest industrial yards, housing yards, and other areas in the city. It's still underdeveloped. The city's not going to release it for residential development. That would just be a shame, but it looks like Williamsburg. So the entire site is being earmarked for innovation and light manufacturing. So if you guys have, if any of you have an idea for a product, it starts in the lab, you test it, you want to set up an office, and you want to do on-site or New York-based manufacturing, then that's the place where you'll find space or look. It's definitely one of the best locations on the East Coast to be doing this. New Lab is inside the Brooklyn Navy Yard. New Lab is it's an 85,000 square foot space. We have all the high-tech companies doing robotics, 3D printing, CAD software, and then we have a bunch of entrepreneurs who are all mechanical, electrics, robotics. We have a whole range of people that are based in the same space, inspiring each other, consulting together, and partnering on building new products. So in Tenix Beta's lab, we have 17 open projects, some of them plastic, some of them mechanical. We're building an autonomous robot car. We're building a power augmented hand cart for FedEx. I'll show something in a prototype video in a second. We have a range of products. There's no limit really, except is it a relevant product? Not a dog tag. Will people want it? Will it be reasonable? Is it going to be scalable? Because you can spend 3 years designing a spoon or a dog tag, and then you end up with no one wanting it. So you have to go through the process and test with it. As a rule of thumb, we say, ask 100 people whether they would want this. Is this just your problem, or is it a real problem on people? This is a bowl that's an extension of the Spoonie line, the pacifier I showed. This is the profile Spoonie that we designed and tested. We did about 100 iterations and settled on that one being the final. This is what the wood spoon looks like in its packaging. That was the sniff tag, some more early engineering drawings where we had to figure out how to settle it on the base station. This base station was like a router that you have at home from. So it took a lot of, a very complex setup. Anybody who would have any issues setting up a Wi-Fi router would have issues setting up this product. So it wasn't the user experience that we have today with smartphones and apps. Whistle is the equivalent company today. A couple of friends asked me advice on whether they should join Whistle, and I said yes, it's a huge market. We didn't get it right because our hardware was too expensive. With this miniaturization and access to scale through using the smartphone as a computing platform, I think Whistle will be doing very well. It's a tiny dog tag, clips on, knows what your dog's doing. It's not social. Our tag knew which dogs your dog interacted with. It would exchange profiles and then ask you if your dog should be friends with these people, and then using the dog as a proxy to be friends with other people. So it's Facebook and Microsoft for your dog in 2006. This is an explorer view that shows that tag. I think what would make this more interesting, and this is tiny, so very, very complex piece of mechanical design. But this PCB was making the thing so expensive because that was a 6-layer PCB. Most of us will only use a 1 or 2 layer. It's 2-layer double-sided, but we had multiple layers embedded to this just for miniaturization. So it was a complete overkill for what the market would bear. That's that again. This was a quick product that we did in 3 days. It was Google came to us and said, can you do packaging that references the cardboard? And we said yes. It had to fit some of the new Android phones, and it also had to be usable. So we basically made a solar panel based phone case. Case breaks apart. It's still usable to charge your phone, and you can take this phone and it's customized for your own Google Cardboard. Okay, that's it. Any questions?
I have 2 questions.
Yes.
First, can you describe your marketing chain and the marketing deals you do to get your products out?
Yes, we have. So we use. I think that process changed a lot in the last 10 years. Our first company was Snapchat. We spent at least $200,000 on PR and going after press opportunities and doing events. It was. That's very much, in my mind, the old school way that we did it. Today, it's very simple. We come up with a product idea, we figure out what's the name of the company, what's the name of the product, what's the name of the brand. Figure that out. And you come up with a bunch of names, and then you say, hey, these 3 names are awesome. Then you go to see, you use some online tools, the US Patent Office, to see, is there a trademark under the name that you like? Does somebody else own that name? Because even if they own the name, it's not a definite no. But do they own that name for the category where you want to use it? So you want to we're making an iPhone case with visual stimulation graphics for kids this summer. And so is it going to be stuff electronics or is it a kid's toy? So check both categories. So we file trademarks for that. Once you have the names, you test what's available, what domains. Can I buy Vermont.com? Or is it either all available? So you sort of go through that initial research process, and as part of that, you go and check all the social media channels. So there are tools that will tell you across 100 platforms the name is used 50%. And then you make an assessment of first owning the name, and then filing the trademarks, and then launching your product. And then launching your product part is you can do the traditional way, where you do it in partnership with a big box retail partner. An MIT startup, Mimo Baby, they partnered with Babies R Us to launch their initial batch. Then went onto a crowdfunding platform to raise the money. They raised a couple of $100,000 on this baby marker. But their first distribution happened through Babies R Us. Babies R Us swapped the 2 packages. There was an accessory and a main product. The accessory was $29. The main product was $200, and they shipped everyone, all those hundreds of thousands of orders were swapped. So as a result, they offered that to ship everything twice. and at some point they couldn't even track what was shipped wrong, what was shipped correctly. So they just offered all of us repeat shipping, discount codes, and I'm like, really just complete mess. That doesn't happen every time that you partner with Macy's. Sorry, not Macy's, with Babies R Us, but it can happen anywhere. It's good to have control over the first step, because during that first step, you're also going to communicate one-to-one with your users. You're going to see what works, what doesn't work. You're going to figure out how to scale the product, whether you want to do it through a boutique network, gift shops. In our case for Spoonie, we want to have the largest group of baby stores in the US buy directly from us. We know that there's between 8,000 and 30,000 stores in the US. Looking at commercial consumer data, and not consumer, but business data. So why can we not build a structure where they buy from us? Why should we? So we're trying to avoid going through a distributor in the US. We're reviewing that right now, if that's the right process. In other countries, we found that for Spoonie specifically, working with a distributor that has reach in those countries has been more successful than trying to enter that market through a direct-to-consumer sale. But a template response for us is saying, we've got a good idea, this is a great product, we're going to put it on Kickstarter or Indiegogo, we're going to tell our story and see if the world likes it. Even if the product is great, if you can't communicate that it's great, it will fail right there. And then you can decide, do I redo that, fix the communication, or do I just let it go? And I think that's one of the best test beds for young entrepreneurs to test products, because if people love it, you have resources to implement it, and you reduce your risk. So you don't have to pay $100,000 on PR, and then you've got a bomb product. The world loves Snowpack, but we never make money from Snowpack.
Hi, thank you so much for coming in today.
Thank you.
I was just wondering, what do you think makes a successful pitch?
Pitch. What kind of a pitch? Investor pitch, product pitch?
Well, what's the difference between the two?
Well, I think every pitch has an audience, right? So if I'm pitching to an investor, I'm telling the investor what the future profitability and potential of my company is, based on product one, but also based on other potential products. So an ecosystem of innovation that will surround that company that they invest in. Investors don't invest in a product, they invest in a team, and they invest in the product idea. But that product idea is ephemeral. I mean, it starts with, it may be multiple products. Tesla is an electric car company. So its investors invested in an electric car company. Now it's evolving to be an electric appliance company. Cars, batteries, and more. So that investor pitch is different from trying to sell the charger to you. When I sell you the charger, you're not so much concerned about the long-term value of the company. The company is, I need to communicate to you the design, the feel, how this is going to make your life better. Why the 85 watt charger is perfect for you and not the 65 watt. And why you've got to pay $20 more for this versus something that you can buy on the gray market or eBay. So it's for every audience, your pitch needs to be sort of customized to that audience. And I think one would ask whether, I want to show some video. And should I have tweaked that a little bit more for this audience? So I feel like I'm just throwing a lot of stuff at you. I'm not asking you for anything in return, so we just have an information exchange. So this is the easiest presentation, it's not a pitch. But as soon as you're asking for money, or asking for something, you need to know exactly what you're asking for, from whom, and why you're asking for it. More questions?
Maybe a good way to understand investor pitch is you're saying to them, I want you to give me this much, and in this many years I'm going to try to give you back this much. Here's how I'm going to do it. It's very different than I just want to sell you this product right now. So I'd say probably the investor pitch probably is a lot more agony than anything else, because you're pretty much asking them to buy into your pipe dream. So.
Yeah, but they're different avenues, right? Because if you believe in your product and no one else does, that's worse than an investor pitch that can still be worked on.
Right. Very true.
Let me show you
Hit
the-
rates of like, 1% on investor pitches, so. That's,
I'm going to just show one more thing. Oh, shoot. Okay. So this is an electric wheelchair that we bought the motors and then we put an Arduino on it, and we are controlling the source of the wheels from a sensor here in the hub. So right here are these supposed sensors in the seating joint which basically know what your directional intent is. There was a very early prototype. We're building the next version of this prototype in the summer. Just want to show it. So this is a hand cart, and the hand cart would so it senses intent. So it's like, for you, it's like you're carrying or pulling a piece of carry-on luggage, or your backpack with wheels, but it can carry 1,000 pounds behind you. So the first version was very dangerous because sometimes the sensor would malfunction and it would drive over your foot. That little cart weighs 50 pounds. So it just doesn't stop. So we're building in safety sensors, collision detection, and so optimizing the steering control. And what that version of the cart would plug in to, let me show you what that looks like. It would plug into a, plug into a cart or a pallet and then push it around the room. So it's much easier to load the pallet. Very similar to an Amazon Kiva robot. We said the Kiva robot is about $100,000 a unit, and these cost less than $3,000. We're using only off-the-shelf parts. So that's one of the projects we have in our lab right now. These are just photos from the lab. We'll show like that. Of us building it. That's a 3D printed handle. You can use a thumb control for the speed, but the speed will be sort of autonomous later, just with collision detection. Okay.
For the cart, how would it stop? It has a sensor for that too?
It would sense that you are putting the handle back, and then it would slow down. And if it senses anything that it can run over, it will stop immediately. So it only goes 5 miles an hour, which is fast enough. I mean, that's very fast for a 1,000-pound load to be moving through a hallway. So as soon as it senses that something is potentially colliding with it will be aware of that sort of safety zone around it. And we use ultrasonic sensors for that. That's it, yeah.
How does it perform on uneven terrain?
So very poorly with those wheels. So what we did is we went to Uline. Those wheels are expensive. They're $80 a piece. You pull them from parts. They're from a robot supplier. We went to Uline, bought $20 wheels from them. Each of those wheels are relatively solid rubber. They're not designed to fit in those motors, but they cost $20. They're solid. And they can carry 400 pounds a wheel. So instead of designing and slaving over the wheel, we just designed the hub that goes inside. And so we have new wheels on this. So the next version will have a much more robust wheel. And that also gives some more stability, but also some deflection and shock absorption. It's very hard to put for something that small an actual suspension system because you don't want to have a suspension system. You just want the wheel to take care of most of that. We could also do an inflatable wheel, but it was less reliable to use the inflatable version of the $20 wheel because of the load requirement, but also because of the hub design, because we made a custom hub out of aluminum for that. Yes.
How difficult is it going from what might be like a long and very involved prototyping process to the manufacturing process, which has to be, cheaper, like more efficient?
Well, throughout the prototype, it's not that difficult, and then it can be also completely cumbersome at the same point. If you have experience manufacturing products, then you design every product with manufacturing and scaled manufacturing in mind. It's a big difference between an idea and the first industrial design and a product that's actually designed for scale.